Are you ready to validate your expertise in AI? Deep learning is the engine behind self-driving cars, facial recognition, and LLMs. But passing the certification requires more than just high-level knowledge. In this video, we will cover AI Deep Learning Fundamentals Practice Questions and Exam Prep Guide. Prepare for your AI Deep Learning Fundamentals certification with this comprehensive practice question set. In this video, we break down 30 high-yield practice questions for the AI Deep Learning Fundamentals certification, covering neural network architectures, backpropagation, and optimization techniques. Stick around until the end to ensure you have the depth of knowledge needed to ace your exam on the first try. What is the primary reason why deep learning is called deep? Option A. Because it requires deep mathematical knowledge to implement. Option B. Because it uses multiple hidden layers in a neural network. Option C. Because it analyzes data from deep within the internet. Option D. Because the training process takes a deep amount of time. The correct answer is B. The deep in deep learning refers to the architectural depth of the artificial neural networks used, while a shallow network might have only one or two hidden layers. Deep learning models often consist of dozens or even hundreds of layers. Each layer extracts higher-level features from the raw input, allowing the network to learn complex patterns. This depth is what distinguishes deep learning from traditional machine learning algorithms like linear regression or support vector machines. Which activation function is primarily used to solve the vanishing gradient problem in deep hidden layers? Option A, sigmoid. Option B, tanh. Option C, ReLU, rectified linear unit. Option D, softmax. The correct answer is C. ReLU, rectified linear unit, is widely used in hidden layers because its gradient is one for all positive inputs. Unlike sigmoid or tanh, which saturate, meaning their gradients become very small for high or low input values. ReLU maintains a consistent gradient for positive values. This prevents the gradients from becoming too small as they are backpropagated through many layers, which is a common issue in deep networks known as the vanishing gradient problem. In the context of gradient descent, what does the learning rate hyperparameter control? Option A. The number of layers in the network. Option B. The size of the steps taken toward a local minimum of the loss function. Option C. The speed at which data is loaded into the model. Option D. The number of epochs used during the training phase. The correct answer is B. The learning rate is a crucial hyperparameter that determines the step size during the wait update process in optimization. If the learning rate is too high, the model might overshoot the optimal values and fail to converge. If it is too low, the training process will be extremely slow and might get stuck in a poor local minimum. Finding the Goldilocks learning rate is essential for efficient model training. Which layer in a CNN is specifically designed to reduce the spatial dimensions, width and height, of the input volume? Option A. Convolutional layer. Option B. Fully connected layer. Option C. Pooling layer. Option D. Dropout layer. The correct answer is C. Pooling layers, such as max pooling or average pooling, are used to downsample the feature maps. This reduction in spatial dimensionality serves two purposes. It reduces the number of parameters and computation in the network, controlling overfitting, and it makes the detection of features invariant to small translations or distortions in the input image. It essentially summarizes the presence of features in patches of the feature map. During backpropagation, the chain rule is used to calculate which of the following. Option A. The forward pass activation values. Option B. The derivative of the loss function with respect to the weights. Option C. The number of neurons needed in the hidden layer. Option D. The accuracy of the model on the validation set. The correct answer is B. Backpropagation is the core algorithm for training neural networks. It uses the chain rule from calculus to efficiently calculate the gradient of the loss function with respect to every weight in the network. Starting from the output layer, the algorithm works backward to determine how much each weight contributed to the total error. These gradients are then used by an optimizer, like SGD or Atom, to update the weights and minimize the loss. What is the primary purpose of dropout in a deep neural network? Option A. To speed up the training process by removing data. Option B. To prevent overfitting by randomly deactivating neurons during training. Option C. To increase the number of features the model can learn. Option D. To replace the need for an activation function. The correct answer is B. Dropout is a regularization technique where, during each training iteration, a random selection of neurons is dropped out, ignored. This forces the network to learn redundant representations and prevents individual neurons from becoming overly dependent on specific other neurons. Co-adaptation. By making the network more robust and less prone to memorizing training noise, dropout significantly reduces overfitting and improves generalization to new data. Which architecture is specifically designed to handle long-term dependencies in sequential data, overcoming the standard RNNs memory limitations? Option A, LENET5. Option B, LSTM, long short-term memory. Option C, VGG16. Option D, AlexNet. The correct answer is B. Standard RNNs struggle with long-term dependencies because gradients tend to vanish or explode over long sequences. LSTMs and GRUS were designed to solve this by using special gates, input, forget, and output gates that regulate the flow of information. This allows the network to selectively remember or forget information over long periods, making them ideal for tasks like machine translation, speech recognition, and time series forecasting. Which loss function is most commonly used for a binary classification problem? Option A, mean squared error, MSE. Option B, binary cross entropy. Option C, categorical cross entropy. Option D, mean absolute error, MAE. The correct answer is B. Binary cross entropy, also known as log loss, is the standard choice for binary classification. It measures the performance of a classification model whose output is a probability value between 0 and 1. The loss increases as the predicted probability diverges from the actual label. While MSE is common for regression, cross-entropy is mathematically better suited for classification because it penalizes wrong predictions more heavily when the model is confident. Which of the following is an example of an unsupervised deep learning model? Option A, convolutional neural network, CNN. Option B, autoencoder. Option C. Recurrent neural network, RNN. Option D. Multi-layer perceptron, MLP. The correct answer is B. An autoencoder is an unsupervised learning model because it does not require labeled data. Its goal is to learn a compressed representation, encoding, of the input data and then reconstruct the original input from that representation. Decoding. This is useful for dimensionality reduction, denoising, and feature extraction. CNNs, RNNs, and MLPs are typically used in supervised settings where labels are provided for training. Why is normalization or standardization of input features important for deep learning? Option A. It ensures all features have a mean of 0 in unit variance, leading to faster convergence. Option B. It reduces the amount of storage space needed for the dataset. Option C. It automatically labels the data for the model. Option D. It eliminates the need for any hidden layers in the network. The correct answer is A. Neural networks are sensitive to the scale of input features. If one feature has a range of 0 to 1 and another has a range of 0 to 10,000, the gradients will become unbalanced, causing the loss function to look like a very elongated bowl. This makes optimization difficult and slow. Normalizing features to a similar scale, like 0 to 1 or a mean of 0, makes the cost function more spherical, allowing gradient descent to converge much faster and more reliably. What does a batch size of 32 signify during the training process? Option A. The model will be trained for 32 total epochs. Option B. The model updates its weights after processing 32 samples. Option C. The model has 32 hidden layers. Option D. The dataset is split into 32 equal parts for validation. The correct answer is B. In mini-batch gradient descent, the batch size refers to the number of training examples used in one iteration to calculate the gradient and update the weights. A batch size of 32 means the model looks at 32 images or rows of data, calculates the average error, and adjusts its weights accordingly. Smaller batches provide a noisier gradient which can help escape local minima, while larger batches provide more stable updates but require more memory. In a neural network, what is a weight? Option A. The physical memory size of the model file. Option B. A parameter that determines the strength of the connection between two neurons. Option C. The number of training samples in the dataset. Option D. A constant value added to the output to shift the activation function. The correct answer is B. Weights are the learnable parameters of a neural network. They represent the strength or importance of the connection between neurons in adjacent layers. During training, the goal of the algorithm is to adjust these weights so that the network can accurately map inputs to the correct outputs. A high weight means the input from that connection has a large influence on the output of the next neuron. Which activation function is most suitable for the output layer of a multi-class classification problem, e.g., identifying 10 different types of animals? Option A, sigmoid. Option B, ReLU. Option C, softmax. Option D, linear. The correct answer is C. Softmax is used in the output layer for multi-class classification because it squashes the raw output scores, logits. into a probability distribution. The outputs of the softmax function are all between 0 and 1. And they all sum up to exactly 1.0. This allows us to interpret the output as the probability of the input belonging to each of the possible classes, where the class with the highest probability is the predicted one. Which of the following describes a 1x1 convolution as used in architectures like Inception or ResNet? Option A. It is used to blur the image to remove noise. Option B. It is used for dimensionality reduction, changing the number of channels, while keeping spatial dimensions. Option C. It is a pooling operation that ignores all but the center pixel. Option D. It is used to increase the height and width of the feature map. The correct answer is B. A 1x1 convolution, also called pointwise convolution, is a powerful tool in deep learning. While it doesn't change the spatial dimensions, height, width, it acts across the depth channels. By using fewer filters than the input has channels, it performs dimensionality reduction, which reduces the computational cost of subsequent layers. It also introduces additional nonlinearity into the network through the activation function that follows it. Which optimizer is known for using momentum to speed up training and navigate past local minima? Option A. Standard stochastic gradient descent, SGD. Option B. SGD with momentum. Option C. Batch gradient descent. Option D. Genetic algorithms. The correct answer is B. Standard SGD can be very slow or get stuck in plateaus, where the gradient is small. SGD with momentum addresses this by adding a fraction of the previous weight update to the current one. Think of it like a ball rolling down a hill. It builds up velocity in directions that consistently lead downward. This helps the optimizer dampen oscillations and accelerate toward the global minimum, especially in areas with high curvature. What does early stopping do to help a model perform better? Option A. It stops training as soon as the training accuracy reaches 100%. Option B. It stops training when the performance on a validation set starts to degrade. Option C. It shuts down the computer to prevent overheating. Option D. It removes the bottom 10% of weights that are close to zero. The correct answer is B. Early stopping is a form of regularization. As you train a model, both training and validation loss typically decrease. However, after a certain point, the model may start to overfit. It begins to memorize the training data rather than learning general patterns, causing validation loss to go back up. Early stopping monitors this and halts training at the point where validation performance is at its peak, ensuring the best possible generalization. In a generative adversarial network, GAN, what is the specific role of the discriminator? Option A. To generate new images from random noise. Option B. To distinguish between real data and the data produced by the generator. Option C. To act as a loss function for the entire system. Option D. To perform dimensionality reduction on the generated images. The correct answer is B. A GAN consists of two networks, the generator and the discriminator. The generator tries to create fake data, like images, that looks real. The discriminator is a binary classifier that tries to distinguish between real data from the actual dataset and fake data from the generator. They are trained together in a game-like scenario. The generator gets better at fooling the discriminator, and the discriminator gets better at spotting the fakes. What is a perceptron? Option A. A type of deep learning framework similar to Keras. Option B. The simplest form of a neural network with a single layer. Option C. A hardware device used to accelerate AI training. Option D. A mathematical formula used to calculate learning rate. The correct answer is B. The perceptron is the fundamental building block of neural networks. Introduced in the late 1950s. It is a mathematical model of a single biological neuron. It takes multiple inputs, applies weights to them, sums them up with a bias, and passes the result through an activation function, originally a step function, to produce an output. Modern deep learning is essentially the result of stacking many layers of these units. Multi-layer perceptrons. Which of these is not a common technique used to combat the vanishing gradient problem? Option A. Using ReLU activation functions. Option B. Batch normalization. Option C. Proper weight initialization, e.g., Xavier, He initialization. Option D. Increasing the learning rate significantly. The correct answer is D. While ReLU, batch normalization, and proper weight initialization are all classic solutions to the vanishing gradient problem, simply increasing the learning rate does not help. In fact, if gradients are vanishing, becoming zero, a higher learning rate multiplied by zero is still zero. Batch normalization helps by keeping activations in a stable range, while Xavier initialization ensures that the variance of signals remains consistent across layers. Which of the following is an example of data augmentation in computer vision? Option A. Adding more layers to the CNN. Option B. Flipping, rotating, or cropping existing training images. Option C. Buying a larger dataset from a third-party vendor. Option D. Using a more powerful GPU for training. The correct answer is B. Data augmentation is a technique used to artificially increase the size of a dataset. Instead of collecting new data, you create new samples by applying transformations to the existing ones. In computer vision, this includes horizontally flipping images, rotating them slightly, zooming in, or changing the brightness. This helps the model become invariant to these changes and reduces overfitting by exposing it to more variety. If you are building a model to predict the exact price of a house, which loss function should you use? Option A. Binary cross-entropy. Option B. Categorical cross-entropy. Option C. Mean squared error. MSE. Option D. Hinge loss. The correct answer is C. Predicting a continuous numerical value, like a house price, is a regression task. The most common loss function for regression is mean squared error. MSE. It calculates the average of the squares of the errors. That is, the difference between the predicted value and the actual value. Squaring the error ensures that large errors are penalized much more heavily than small ones. And it ensures the result is always positive. Which deep learning framework was developed by Google? Option A. PyTorch. Option B. TensorFlow. Option C. Scikit-learn. Option D. Caffe. The correct answer is B. TensorFlow is an open-source library for machine learning and deep learning developed by the Google Brain team. It is one of the most widely used frameworks in the world, known for its scalability and support for production deployment via tools like TensorFlow serving PyTorch. Its main competitor was developed by Meta's, Facebook's AI Research Lab. Why are GPUs preferred over CPUs for training deep learning models? Option A. GPUs have more memory capacity than modern CPUs. Option B. GPUs are better at sequential processing of logic tasks. Option C. GPUs can perform thousands of small matrix calculations in parallel. Option D. GPUs are less expensive to operate than CPUs. The correct answer is C. Training a neural network involves millions of matrix multiplications and additions. A CPU is designed for complex, sequential logic. It has a few powerful cores. A GPU, however, has thousands of smaller cores designed for parallel processing. Since the math in deep learning can be broken down into many independent operations, a GPU can process these in parallel, making training significantly faster, often 10x to 100x, than a CPU. What is the function of a bias term in a neural network neuron? Option A. To prevent the model from learning from specific features. Option B. To allow the activation function to be shifted left or right. Option C. To multiply the input signal to increase its strength. Option D. To determine the number of neurons in the next layer. The correct answer is B. The bias is an extra parameter in a neuron, added to the weighted sum of inputs before the activation function is applied. Mathematically, it's like the y-intercept in the equation y equals mx plus b. Without a bias, the activation function would always pass through the origin 0, 0. The bias allows the model to shift the activation function, giving the network more flexibility to fit the data and represent patterns that don't pass through the origin. What is teacher forcing in the context of training sequence-to-sequence models? Option A. A method where the teacher manually labels the data. Option B. Using the actual ground truth output from the previous step as input for the next step during training. Option C. Increasing the learning rate when the model makes a mistake. Option D. Forcing the model to use a specific architecture regardless of performance. The correct answer is B. Teacher forcing is a strategy for training RNNs. Like in machine translation, normally, the output of the model at time t is used as the input at time t plus 1. However, early in training, the model's outputs will be wrong, leading to a cascade of errors. Teacher forcing fixes this by providing the asterisk correct ground truth word at each step during training, allowing the model to learn much faster. What does stride refer to in a convolutional layer? Option A. The height of the filter used. Option B. The amount of padding added to the edges of the image. Option C. The number of pixels the filter moves across the input at each step. Option D. The total depth of the feature map. The correct answer is C. Stride is the step size with which the filter, or kernel, moves across the input image. A stride of 1 means the filter moves 1 pixel at a time. A stride of 2 means it jumps 2 pixels. which effectively reduces the spatial dimensions of the output feature map. Larger strides lead to smaller output volumes and can act as a form of downsampling, similar to pooling. What is transfer learning? Option A. Transferring a model from a local machine to the cloud. Option B. Using a pre-trained model on a new, but related, task. Option C. Converting a PyTorch model into a TensorFlow model. Option D. Moving weights from the hidden layer to the output layer. The correct answer is B. Transfer learning is a powerful technique where you take a model that has already been trained on a massive dataset, like ImageNet, and fine-tune it for your specific task, like identifying different types of leaves. Since the pre-trained model has already learned how to detect edges, shapes, and textures, you don't have to train it from scratch. This saves massive amounts of time and data, often producing better results. Which of the following is a symptom of a model that is overfitting? Option A. High training error and high validation error. Option B. Low training error but high validation error. Option C. High training error but low validation error. Option D. Both training and validation error are 0. The correct answer is B. Overfitting occurs when a model learns the training data too well, including its noise and random fluctuations. As a result, the model performs exceptionally well on the training set, low error, but fails to generalize to new, unseen data. High validation error. It's the equivalent of a student memorizing specific answers to a practice test instead of learning the underlying concepts. How does the Atom optimizer differ from standard SGD? Option A. It uses a fixed learning rate for all parameters. Option B. It calculates adaptive learning rates for each individual parameter. Option C. It is an unsupervised optimization algorithm. Option D. It only works for shallow neural networks. The correct answer is B. Atom. Adaptive moment estimation is an advanced optimizer that maintains a separate learning rate for each weight in the network. It does this by tracking the moving averages of both the gradients, first moment, and the squared gradients, second moment. This allows it to automatically speed up training for parameters with small gradients and slow down for those with high variance, making it very robust and often the default choice for deep learning. In a neural network, what is an epoch? Option A. One single update of the weights using a mini-batch. Option B. One full pass of the entire training dataset through the network. Option C. The time it takes to train the model to 90% accuracy. Option D. A specific type of activation function used in transformers. The correct answer is B. An epoch represents one complete cycle through the entire training dataset, because the weights are usually updated using mini-batches. One epoch consists of several iterations. Number of samples, batch size. Most deep learning models require many epochs, e.g., 10, 50, or 100, to converge, as the weights are adjusted slightly in each iteration to gradually minimize the error. That concludes our 30 practice questions for the AI Deep Learning Fundamentals certification. We covered everything from basic perceptrons to advanced GANs and LSTMs. If you found these explanations helpful, hit the like button and subscribe for more AI certification prep content. Don't forget to check the link in the description for the full-length practice exam. For the full practice exam and additional study resources, check the link in the description below.